friends, it's Mrs. Berger, and I'm here for another lovely video, joined by
Mr. Lamb, here to do another fun day of videos with my favorite teacher.
That's right, my favorite teacher. Here we go. All right, so today we're going to talk about inequality keywords. We're going to translate verbal inequalities.
Ooh, I like translating.
Ooh. So your learning target, I can translate inequalities using key words. Well, why, Mr. Lamb, is it important to translate these inequalities?
Well, we know that the hardest thing about word problems is taking a look at them and figuring out, like, what are the words trying to tell us, and then we have to turn them into mathematical sentences.
Right. So we're going to take words and make them numbers.
Ooh, I like that.
Or
mathematical sentences.
Well, that's true. Or we're going to take numbers and make them words. Right? When we translate, we're going to turn something from one language into another.
But today we're mostly going to concentrate on taking those words and turning them into numbers.
That's true, right? A number sentence or mathematical sentence.
And in this case, we're talking about inequalities, not equations. Normally when we do this, we do equations. Well, this is inequalities.
These lovely students have already done equations, so they should have like a pretty good understanding of how to do this.
Of how to do the inequalities, yes.
Right. So obviously, again, just a review on words that mean add, subtract, multiply, or divide. And this graphic can also be found in your digital notebook, so you can always look at that if this is kind of hard to read.
And this is really a very small sampling. We did this, if you remember back when we did equation.
We did.
We did a great big thing where they had to move them around the thing. So you pretty much already know this. This is just kind of a review.
But we have to remember the four main ones, right? That sum, S-U-M, means addition.
Yes.
Difference, subtraction. Product, multiplication.
And here's the one that always forget.
Quotient is division.
Yeah,
But instead of focusing on just what's the operation, with inequalities, we also have to look at words that will tell us what symbol to use.
That's right, because no longer are we looking for that equal sign.
Right.
Now, because they're inequalities, we're looking for those inequality signs. So we've got to figure out what words mean those inequalities.
Right. So we have less than or equal to, greater than or equal to. But there's also other words that will let us know
Matter of fact,
what inequality.
Teachers are kind of funny. We probably won't put less than in the word problem.
Not a ton.
No, we'll probably put things like fewer than.
Or smaller than.
Or smaller than, or below.
Below, right? Something that would signify that one side was less than the other.
So if I was out there instead of here, I could be writing these down.
Right, and this graphic can also be found in your digital notebook too, if you want to take and like have more time to write it down in case we go too fast.
Well, they could always pause it, write them down if they want.
That's true. You could pause.
Yeah, there's one thing I think we all forget is I just can't hit that pause button.
That's right. It'd be nice to pause teachers in real life. Okay. All right. So with less than or equal to, we're looking for not just is less than or equal to, like obviously, but no more than, or at most,
or maximum,
or not greater than. Right. So we're looking for those keywords. Well, what about,
Well, and the reason that those are in here is because it's like we got to take care of that equal sign now, right? Because one of the numbers can be equal to something.
That's true.
So that's why there's actually a little bit longer.
Or less than, right? So when we have is greater than, we could also use something like more than, or
exceeds,
or larger than,
or above.
Yeah. So all of those would signify that the number was greater than the other.
And again, this isn't what we would call an exhaustive list. An exhaustive list is like every possibility known to mankind.
Right, we don't have time for that.
We just use the most common.
The most, yeah. The ones you'll see the most, right? But for greater than or equal to, we would look for things like no less than.
Or at least.
Or a minimum.
Or not smaller than.
Those would be good keywords. So let's actually do some of these translations. Do you want to do the first one?
Sure.
Okay.
Now, these aren't actual word problems yet. These are like just fragments. Can you pick out what sign it is?
Right.
So let's look at this first one.
But we're translating it, words into a number sentence.
You must be at least 48 inches tall to ride this roller coaster. So let's think about that. If I have to be at least 48 inches, then I know 48 has to be one of my numbers, right?
Okay.
That's true. Now, Could I be 47 inches? Well, no, because that's not at least 48.
No.
So, could I be 49?
Yes.
50?
Yes.
51?
Yep.
So then I'm looking for greater than or equal to 48.
Right, and we can use any variable, right, to really cap off that
Thank
sentence.
you, because I probably wouldn't have put a variable there.
So we could say x, the variable, is greater than or equal to 48 inches, because you could be 48 inches exactly and ride the ride, or 48.5, 49, 50, you could be 60 inches, 70.
Which means you and I could both ride the ride, but your daughters
could not ride the ride.
Could not ride the ride because they're too short.
Yeah, and my husband was like close. No, I'm just kidding.
Oh, I'm telling.
He doesn't watch these, so it's okay. My husband's kind of short. Or I'm just a little too tall. One or the other. All right, so we took those words and we made it an inequality number sentence.
Why don't you do the second one?
Okay, so it says, this kid's ride, the kid's ride is for those smaller than 3 feet, right? So you have to be smaller than 3 feet. So x has to be less than, if I'm smaller than 3 feet. But I can't be 3 feet exactly.
No.
Because 3 feet isn't smaller than 3 feet. 3 feet is 3 feet.
Yeah.
So in order to ride that kid's ride, the child has to be less than 3 feet.
Excellent. Okay? So now, no more than 7 people are allowed in the store at a time. You know, you see a lot of these signs now. Because of what's going on, because of that COVID stuff.
Yeah.
Right? They don't want a lot of people in. So this is one of those ones that's kind of practical.
Yeah.
Okay, so no more than 7. Which means 7 people can be in there.
You could have 7.
You could have 7. But no more than 7.
So
this is going to be less than or equal to 7.
Right.
So x, I don't write that well. She writes off that.
Oh, gosh.
X, but you understand what it says, so it's good enough.
So it's fine. So the number of people has to be less than or equal to 7. Which you can have 7 people, or 6, or 5, or 3, or 2.
You can even have just 1.
Or 0 people. No one can.
Yeah, there could be nobody in the store.
Right, and we're using the variable x because it's the most common, but these could be any variable,
Oh yeah, you
right?
could use y, you could use z.
We could do a is greater than or equal to 48, and those would all be correct, right?
Yes.
But in order to signify the missing thing, the unknown thing, we have to plug in some sort of variable.
And we always use lowercase.
Remember, the variable's the letter.
Yes.
Right? Okay. So let's look at a word problem.
This is actually a full-fledged, one-step equation word problem.
Full-blownsies. And this is really a practical situation that's happening in our lives right now, too. It says the COVID rules at school say no more than 1 person per seat are allowed on the bus.
So, key words here.
Oh, sorry.
It's okay.
Here we go.
So we got no more than
1 person per seat on the bus. There are 21 seats on the bus, and 11 students are already on the bus. Write inequality to figure out how many more students can be picked up by the bus. Okay, so let's think about it. So I want to figure out, there's 11 kids on the bus.
So 11 has to be in.
So there's 11 kids already there, right?
Yep.
We can have no more than 1 person on a seat, and there's 21 seats.
So could we have 21?
No more than what? Yeah, we could have 21.
We could have 21. So that's going to be one of our numbers.
Right. But people on the bus have to be less than or equal to 21.
Exactly.
So I have to figure out, well, how many more students can I have? So the number of more students plus the 11 that are already on there have to be less than or equal to 21. So here's my number set.
So now she's written her inequality.
Boom.
So now we're going to solve it.
Right, so I solve an inequality just like I solve an equation,
That's right. Get rid of the stuff that's on that same
So
side.
I'm going to take the stuff that's on the side with the variable, and I'm going to get rid of it, right? So x plus 11, the opposite of plus is minus.
There you go.
So I'm going to minus 11 to this side, and whatever I do to this side, I have to do to this side. That goes away because inverse operations cancel each other out. So I have x. I'm going to just drop down my inequality sign.
Yep.
And 21 minus 11 is 10.
So basically, we're saying that, remember now, this is an inequality, which means there's not just one answer. It's a set. There's an answer set. A solution
set.
Ooh, I even like that better. Okay, so could you pick up 10 more?
Yeah.
Sure. Could you pick up 11 more?
No.
But you could pick up 9 more, 8 more, 7 more. You could pick up no more.
Right. So all of those are numbers that are
in fact, you can kick 2 or 3 kids off the bus and end up with negative numbers.
That's true. Don't act a fool on the bus, don't get kicked out. So my solution is x is less than or equal to 10. And the numbers that make that sentence true are part of my solution set.
And so that's translations, right? We took all these words and we turned it into a nice math sentence. Then we solved the math sentence, we solved the problem.
Right. We're brilliant. All right. If you're still confused, watch that next video. But if you feel like you've got it, then you start that practice for today. And we'll see you later. Love ya.
Bye. Talk to you next time.